Hi class. So on our list of inorganic compounds, we also saw acids and bases. So very important for biology. Okay, what we're going to look at with acids and bases is kind of a basic definition and then what's called the pH scale. We can measure acids and bases using the pH scale, which is a super common biology thing. All right, so an acid, what we're going to do with our definitions is kind of look at what if we put one of these things in water. So if we put an acid in water, that's always going to release H plus. Okay, so this is a hydrogen ion, H plus. So we just kind of associate H plus with acids. Okay, and then if we put a base in water, it's going to release an ion that's written like this, OH minus. Okay, and that is referred to as the hydroxide ion. So we're kind of looking at the balance of hydrogen ions and hydroxide ions. Okay, as I mentioned, we use something called the pH scale to measure acids and bases. Here, a lot of things when we're studying biology where we look at the pH of something. Right, so our pH scale, it's going to go from 0 to 14. And I'm putting 7 in the middle because 7 is important. Okay, so 0 to 14. Okay, for 7, what we have with 7 is what's called a neutral pH. So a pH of exactly 7 is neutral. It's not an acid and it's not a base. So what this means is the amount of H plus equals the amount of OH minus. Okay, those have to be equal for it to not be an acid or a base. Okay, anything below 7, so I would say just kind of think like this, 0 to 6.9. Okay, that's going to be an acidic pH. Okay, these are our acids. The amount of H plus is greater than the amount of OH minus. And then anything higher than 7, 7.1 to 14, these are our basic, or what are also called alkaline pHs. So basic or alkaline pH greater than 7, 7.1 to 14. So H plus would be less than OH minus. Right? So, bottom line is kind of if it's an acid, H plus is higher. If it's a base, OH minus is higher. And then if it's exactly neutral at 7, these two things are equal. Right? So that's how we're using the pH scale and what it means and how we're actually using it to measure the strength of an acid and a base. And I just mentioned the strength idea, so let me clarify that for a second. So as we approach the end of this scale, things get stronger, right? So stronger acids down here, stronger bases down here. Right, so if we had a couple of pHs, if we had a pH of 8 and a pH of 13, and we wanted to know which one of these two would be the strongest base, that would be 13. Right, so the ends of the scale are stronger acids and bases.